z axis, the angular momentum of this one. So angle of inclination is theta. Let this be O. The inclined plane. A block means it will have cubical block, side length A, mass M. Now what is the angular momentum of that? At t equals 0, it was here. After some time t, I'm asking, what can be the angular momentum of this particular block? I'm pulling you to some laws of motion concept. Sir, about what point? About origin. Angular momentum about the origin. How to do this? Shall we say 0? No, it cannot be 0, no. At t equals 0, the block is here. After some time t, it will be available here. So what is the distance it will cover? It will cover a distance s. So what is s equal to? V into t. So now get into the center of mass here. So here shall we say it will be this s we know. So can we calculate this distance y, and it will also cover x distance. And look at the block. You look at the block here. There's the inclined plane. There's a block. Only let's focus on center of mass here. There's a x-axis, there's a y-axis, and the center of mass, what happens, will move parallel to incline. Agreed? Now what is the distance? A by 2. And this is what the velocity of center of mass here. So at t equals 0, so let the center of mass be at here. So what is the distance covered? Equal to s. No, I think this is what we can define it here, no? After some time, so this distance is what you call x, and this distance is what you can call y. Now it will have velocity. So resolve this velocity, Vx and Vy. So then what is the angular momentum? LOZ should be equal to mvx into y clockwise, mvy into x anti-clockwise. So what are Vx and Vy? Component of velocities. And what are x and y? I think we know the distance covered s. We know the distance covered s, and from that s, what happened? You should calculate the y and x, that one. And s is till here. The s is measured till here, not till here. The s is measured till here. So you take care about this distance is what? A. And you know this is theta. So calculate, and you have what you have to do is like till here is what the distance is, that one. Fine. This one. So this y has to be calculated here. So for till here, so what happened? You can get one distance. For that, what happened? You had this particular thing. Then you get the total y. So what should be the like a y should be equal to? Look at the triangle. So this will be theta, no? This distance is what? S sine theta. Then further what happens? You should add up that A cos theta. Similarly, for you calculate the X value. Similarly, you calculate that you have to subtract because center of mass is here, no? So what is the displacement of center of mass that you have to calculate? So you should take care about this distance. So some geometry based problems will come. Try to work out. I'm just giving some basic idea. Y is not S sine theta. The Y is total this distance. Do calculation. It's a geometry base. I'll go for the next concept. This is about the particle moving. This one. So let's go for angular momentum of rotating rigid body. L of a rigid body rotating about fixed axis. What is the angular momentum? So we define. So best example, let me take a circular disc. So let me take a particle at a distance small r.